Right, okay, with this question, we're asked to describe how asexual reproduction differs from sexual reproduction. Right, A means away from or not. So sexual reproduction, you need a gamete, a sperm and an egg, or it will be a pollen and an ovule. This is done via meiosis, and it involves fusion of the sperm and the egg to give for fertilization to take place. With this, you get genetic variation. Right, okay, and that's it. And then the opposite for asexual. So we can say, we can put that there for sexual. Now let's do it from the asexual side. So we'll say no gametes formed, and also no cell division via meiosis. Right, so no fertilization takes place. Right, you just have runners, you have tubers, you have bulbs. They reproduce each year. Right, there's no genetic variation. So there's no genetic variation. They are genetically identical. Okay, you can say it both ways. So only one parent cell is required. So from the parent, so yeah, we can say only one parent cell is required. Right. As opposed to both sperm and egg, you only need one parent cell. Yeah. Okay, let me just, that's that bit done anyway. Right. Remember, you've got the word haploid is for sperm. It has 23 chromosomes. Diploid is the ova or the egg, and it has 23 chromosomes. And then when they fuse and fertilization takes place, you end up with 46 chromosomes. Oh, did I just say diploid? Oh my god. That's what happens when you get old. Haploid. This is haploid. And then it becomes 46 chromosomes, becomes a zygote, and you end up with a diploid cell. Right, let's move on. That there is the fallopian tube or oviduct. This is an ovary. That is the uterus or the womb, and this is the vagina. What is the site of fertilization? Where is... Okay. A. Right. Remember that we said they call this also the oviduct. Where does the fetus usually develop? It's in this area, in the womb. So that is C. Describe the role of the hormones produced by structure B. Where is structure B? Okay, ovaries. Right. 4 marker. Right. Describe the role of hormones. Okay, estrogen. So we end up with 2. Estrogen, progesterone. So estrogen thickens the uterus lining, ready to accept a fertilized egg. And estrogen is also responsible for the development of secondary sexual characteristics. Then you've got the other hormone called progesterone. This helps maintain the uterus lining, ready to right, okay, yeah, progesterone helps maintain the uterus lining, ready to accept. No, so the estrogen thickens it and progesterone maintains it, and then when there is no fertilization, you end up with the period and it sheds it. I think that's it. Oh, right, okay. Right, let's keep going. The male reproductive system in humans produces sperm in a liquid called semen. The production of sperm changes with age. Scientists investigate how age affects mean semen volume and sperm concentration. So it goes down with age. The concentration of sperm goes up, and then the concentration goes down a bit, and then it goes up, and then maintains at 62, and then it starts going down. Right, okay. Mean number of sperms released is 200, 200, 200, 200. Ooh, we've got to work that out by the looks of it. 180, 105. So it drops off. Right. Calculate the mean number of sperms released in one ejaculation from men from the age of 40 to 43. So, right. So, what did they do? Mean sperm concentration per centimeter cubed. Right. So they did. Right. Let's check. Where are we? Let's check that one. Right. Let's check to see if it's 3.30 times 61.6. Yeah, it does give 201.63, so they've rounded it up to 202. So to work this out, we do 3.22 times 62.1 gives 200 million. Right, okay, we got that. Explain why the mean number of sperms released is a better measure of fertility than the mean semen. Because you've got more in terms of volume. The number of sperm depends on, yeah, so you could have a high concentration of sperm per centimeter cubed, but low volume, which means less sperm. So the number of sperm depends on volume and concentration. Yeah, so you can answer it from, so that's your first mark, and the second one, you can have high concentration but low volume, or you can have high volume but low concentration. So that means you've got less chance of getting pregnant. Calculate the percentage decrease between 37 and 48. So right, those are the two numbers we need. Let's do it here. Where are we? There you go. It stands that bit. So what we do is we do 202 minus 142. So the difference is, let me get this right, 60. And then you do 60 over the original. It always is the original. Okay. And then to turn that into a percentage, you do that. And it should be 29.7%. Let's check that. 60, right. No, 202 minus 142 divided by 202 times 100, and it gives a magical figure of 29.7. Yep. So the answer comes out as 29.7029 with recurring, and they've rounded it off to that, which is fair enough. That's it, done. Right. Hey. Right, let's try to squeeze this in. You've got a food web. This is a producer, it makes its own food. This is a producer, it makes its own food. This is a primary consumer. This is a secondary consumer, and this is a top predator or tertiary. Let me write it properly. Tertiary consumer. Right. Name the producers in this web. So it will be the boulder rack, and microscopic algae. Okay, so it's this one and microscopic algae. Right, what else is there? Oh, name two secondary consumers. So primary, secondary, crab and lobster. The seal can be as well. Look, because if you look at this, that's your primary, and the seal is eating that. So in this path, on this path, it's a secondary. But if you go via this option, oh, not that option. Right, sorry. Oh, okay. So sorry. If you go, let me undo that. I'm just gonna cause confusion. Right. Okay. Let's do this. So you've got 1, 2, 3. So it'll be tertiary on that. Right. So two secondary consumers would be crab and lobster, the most obvious one. Lobster, and then you can also get a seal and a look. 1, 2, herring gull. Right, okay. Food. Right, draw food chain that contains 4 organisms, including the herring gull. So, right, let's get this right. Let's get rid of that. Right, herring gull. So we want this. We want that at the top. So what we're going to do is we're going to do it here. Herring gull. Now, right. So you've got, we're going to go down the crab route. So you get that. And the crab eats the flat winkle and where are we? There we are. Boulder rack. Did I say boulder rack? Boulder rack. So that is our food chain. Includes the herring gull, and it's got 1, 2, 3, 4. Does it say 4 layers? 4 organisms. There you go, done. Right. This food chain is found in the food web. Microscopic algae, limpet, lobster, common seal. Sketch and label the pyramid of energy for this food chain. Okay. So we are expecting microscopic algae. We're expecting millions of them, yeah? Microscopic algae. Limpet. So we're expecting common seal there. We're expecting handful of lobsters. Right. If I put that too far up, it doesn't matter. We'll bring it down. And limpet. So let me bring these down. Okay. Right, that's not very good. That, do you know why? Let me just draw the microscopic algae, so you've got the limpet, and you've got the lobster, and you've got the common seal. That's it. Explain why the amount of food. Right, this is again is a standard answer. So the amount of energy available to organism changes along this food chain. So what they're saying is basically, it's the example that's in the book. It's the rabbit. So you've got, just say 10 kilograms of grass, right? I'm going to just assume that that's 10 joules. Why doesn't the rabbit increase by 10 kilograms or gain 10 joules of energy? Right, first of all, this is a standard answer. Not all the food is eaten. Secondly, some food will die and decay or decompose. Right. Some energy is used up during respiration. Respiration is where the body uses oxygen to release energy from glucose or from one of the molecules. Right, and some is lost through respiration or cell waste. And it's good just to put in urine, excreted, lost through cell waste, through cell excretion or waste in urine. That's it, that'll be more than enough. Some is used, some energy is lost for movement, because you need to move to get to the food or run away from predators, or yeah, some is lost through movement. So, and as you're moving, you're producing heat, right? Again, these are standard answers. They appear a lot. Right, okay, that's that question done.